It's 1939. Germany and Britain are at war.
This is an all-consuming conflict. At stake, nothing less than the future of the free world. To combat the Nazi threat, the Allies are using not just weapons, but brains.
Here at a place called Bletchley Park, just north of London, a group of mathematicians and scientists are working on a top-secret project. A project so crucial that its success or failure will determine the outcome of the war.
Their mission was to crack the German Enigma code, the technology used by the Nazis for all their secret military communications. Now, intercepting the radio transmissions was easy, but unless they could decode them, they were useless.
And this is what they were up against, an Enigma machine. And the way that it works is it takes a message and it converts it into a seemingly random combination of letters.
Precisely which letters depends on the position of these three rotors.
Now, to make it more complicated, each time you hit a letter, it changes by rotating these rotors.
So now, that same letter becomes an F, and now a B. The key to the code was the position of the rotors at the start of the message. Every machine on the network used the same initial settings, a three-letter code that was changed every day.
The challenge here at Bletchley was to figure out what that three-letter code was, because once you unlocked that, you got all the messages that were being transmitted that day.
To even begin to crack the code, they first needed to find a fragment of coded text and the original message. The breakthrough comes when they discover that particular operators have their own telltale patterns. Like the German operator stationed in Norway, who always starts his first message of the day exactly the same way, giving the code breakers what they need: a piece of encoded text along with its decoded message. And the phrase that enables them to find the key to the code? The simple greeting, "Good morning." Next, the code breakers had to find the Enigma settings that would turn that code back into the German phrase. No simple task, given that the Enigma machine had 158 million possible combinations. Eventually, this was the solution they came up with. A machine called the bomb.
What we have here, on the top bank alone, we have 12 Enigma machines. 3 drums, 1, 2, 3, relate to the 3 rotors in the Enigma machine.
All right, well, let's try it.
The bomb was built using the same technology that Hollerith had developed to process punch cards. It can run through 1,000 possibilities every second in search of a setting that might decode a message. When it finds one, it comes to a halt.
So this tells you this may be the Enigma setting that encoded the message.
For one day.
Wow. Because doing this by hand would take what? Months?
Years.
The ability to crack the German Enigma code became one of the most valuable tools in the Allies' armory. It provided intelligence in the Battle of Britain and helped the Allies to counter the U-boat threat in the Atlantic. It's said that breaking the code helped shorten the war by 2 years. But then the Germans started using an even more complex code, the Lorenz cipher. And to crack that, the team at Bletchley produced an even more advanced code-breaking machine.
They swapped out the mechanical switches and dials for electrical valves, creating the world's very first programmable, electronic, digital computer, the Colossus.
It's staggering to think that this was built just 70 years ago. It has less than 1/100th of the computing power of my phone, and yet this marks the beginning of the information age.
So it's sort of phenomenal seeing the basis of your career, where it started. Like, most of what I've done has been around technology and computing. And this is where it started. This is the seminal moment that then led to the information revolution that's occurred just in our lifetimes. It's just awe-inspiring.
Just 10 years later, electronic computers were being made commercially, and one of the leading computer companies was Hollerith Tabulating Machine Company, which had now changed its name to International Business Machines, or IBM.
In the 1980s, IBM releases their personal computer, the template upon which most modern computers are based. Now, thanks to the PC, each of us has the ability to process an enormous amount of information. Which brings us back to the IndyCar. Because all that processing power, the ability to crunch massive amounts of data in a short period of time, has become crucial to motorsports.
It's the day before the big race, and the Penske team have just a few hours in which to get these cars running at peak performance. And the key to doing that is data.
Every one of these cars is packed with sensors measuring the forces, acceleration, the engine performance 1,000 times a second. Information is being beamed back trackside real time so the engineers can see exactly what's going on with their car.
Every time the car comes into the pit, its data is used to make instant adjustments. And that means processing it at ultra-high speeds. Just a few years ago, this level of data processing would have been impossible. Now, it can be done on an everyday laptop. So how did we get here? We began with the heavy plow that contributed to the food surplus behind the growth of medieval cities, whose filthy conditions led to the spread of the Black Death. This resulted in a shortage of workers, which helped trigger the invention of Gutenberg's printing process. That gave us polymaths like Simon Stevin, the man who perfected the windmill, the invention that inspired the design of the propeller, which in turn led to an increase in immigration to the US, building the need for Hollerith's tabulator that helped to create the code-breaking bomb, the inspiration behind the modern computer.
Of course, this revolution in data processing has applications far more significant than motor racing. Today, we're surrounded by data. Every day, we use and process more and more digital information. It affects every aspect of our lives. Some people are even using it to fight terrorism.
Today, the technology exists to sift through the billions of emails and messages sent every day, searching that data for suspicious text that might indicate a terrorist act, to automatically decode speech and hunt for key phrases and names that link to intelligence targets. Computers can even analyze CCTV data in real time to identify faces and cross-match with a wanted list.
This revolution in processing power stands to utterly change our world. And if the links in this story are any guide, the future's going to be more surprising than we can possibly imagine.